So today, this is lesson 11.3, spinner experiments. This is the parent help video for grade 3 everyday math. There are a few things we want kids to know during this lesson. Although there aren't any new vocabulary words, we are expecting them to remember some probability terms. And probability is how likely something is to happen. Probability. So it's how likely something is to happen. And that's what we're looking at during this lesson. And so we want kids to be able to use probability terms. It's not likely, it's very likely, it's equally likely. Okay, so not likely means it probably won't. Very likely means it probably will. Equally likely means you got like a 50-50 chance. Okay, so not likely, nope. Very likely, probably. Equally likely, 50-50. Okay, so just to kind of give an idea of the language that we're going to be using, even though no new words are actually introduced in this lesson. We want kids to be able to shade the fractional parts of a circle. So if I have this circle here, and let's say kids are instructed to shade 1/2 the circle green, we want them to be able to say, well, okay, this is half the circle, so I'm going to shade it green. Okay, and it doesn't matter which pieces they actually shade green, as long as 4 out of those 8 pieces, because there's 8 pieces in the whole in this case, as long as this much of the circle is shaded. Okay, that's what has to be shaded. And then next, let's say 1/4 of the circle is going to be brown. Alright, so we'd want them to say, well, I know that 2 out of 8 is going to be 1/4. Alright, so 2/8 of these pieces are going to be shaded brown. Alright, and then let's say 1/8 of the circle is going to be red. So we want kids to be able to shade 1/8 of the circle red. And then we'll say 1/8 of the circle is going to be orange. So we'd want them to be able to shade that orange. Okay, so just being able to shade those fractional parts of a circle is a key piece of this lesson. We want them to be able to, when they're doing the shading, to be able to think in terms of equivalent fractions. So that's actually another good word, equivalent fractions, which we talked about during our fraction unit. But equivalent fractions are, you'll remember, fractions that are equal, right? That are equal, fractions that are equal. So for example, when I shaded this 1/2 of the circle green, I knew that 1/2 was equivalent to 4/8, right? I needed to know that in order to shade 4 out of those 8 pieces green. So we want them to know equivalent fractions. 1/4 of this circle, well, 1/4 I needed to know was equal to 2/8, because I shaded 2 of those 8 pieces. Alright? Because in this case the circle was broken up into 8 pieces. Now the circle could have been broken up into 6 pieces, it could have been broken up into 24 pieces. Okay? We need kids to be able to figure out those equivalent fractions in order to shade the correct number of pieces. Now, the next thing that we are talking about are probability experiments. So if I take a paper clip and I spin it around on this circle, how likely is it that it will land on a certain color? Alright, if we were to just look at this circle, we see that there's a lot more green than there is orange, for example. So we could say, if I was going to spin this paperclip around, my paperclip will be more likely to land on green than orange. Okay? It doesn't mean it always lands on green. It just means it's more likely to land on green than orange because there's more green in the circle. Right? There's a bigger chance it would stop where there's more green. On the other hand, we see that the red, which is 1/8, and the orange, which is 1/8, are going to be the same size. So they are equally likely. It's equally likely to land on orange as it is to land on red. okay? Because these are the same size here, all right? Even though these are the least likely, right? If we were to look at this, whole circle as a whole, it would be not very likely to land on orange compared to the rest of the circle. It would be more likely, right? It would be very likely to land on a color other than orange, right? Because orange is just a teeny tiny piece, all right? So you're kind of taking your chances when you spin it. And we want kids to get the idea of knowing, well, there's more green, so it's going to be very likely or much more likely to land on green, all right? And there's only a little bit of orange, so it's going to be less likely or not very likely to land on orange. All right, so we want them to be able to think about that. We want them to be able to actually do one of these spinner experiments to make a prediction. You know, maybe they make a prediction how many times it's going to land on certain colors out of 10 spins. So let's just say we have 10 spins. I'll demonstrate this. And look, we will take the different colors. So we'll take green, brown, red, and orange. Okay, and we're going to record the results for each of those. We're going to record the results for each of those. Now what can happen is we could actually make predictions first. I could actually make a column here for my predictions and then say, well, okay, I think out of 10 spins, 5 of them are going to land on green, 2 will land on brown, 1 will land on red, and 2 will land on orange. I think that adds up to 10. Yeah, 5, 2, 1, 2. Okay, that should be 10. So I can make a prediction, but what I'm going to do is actually just fill out, this is a frequency table. Okay, we've been working with frequency tables, and frequency tables show how often something happens. So we want kids to be able to use one of these frequency tables with the spinner experiment and record their results. Alright, so watch. It's actually not too tricky. So you can use the paper clip and you just spin it around. Okay, green. Put a tally for green. Next spin. Orange. Put a tally for orange. Brown. Put a tally for brown. And you know, if it lands on a line, just pick one. You know, we're not going to get too excited about which one is which. Red. A tally for red. Okay. Let's see, we'll do 10. Brown. Red. Green. Green. How many have I got? 3, 4, 5, 6, 7, 8. I need 2 more spins. Green. And I need 1 more spin. And green. Okay, so number 5, 2, 2, 1. And if I look, does this make any sense? Right? Let's see what this table says. Does it make any sense to us? So in all, I had 10 spins, didn't I? I had 10 spins in all. So I'm just going to write total here. And the total was 10. So I got 5 out of those 10 spins were green. Right? 5 out of those 10 spins were green. 2 out of those 10 spins were brown. 2 out of those 10 spins were red. And 1 out of those 10 spins was orange. Okay? So just so we can have this color key beside us so that it's easier to follow. If we look at that, we kind of have to think about it. Does that make sense to us? Well, this 5 out of 10 one definitely makes sense to me. It makes sense to me because 5 out of 10 is exactly 1/2. Exactly 1/2 of this circle is shaded. And it landed there exactly 1/2 of the times. So I'm really happy with this result here. Now let me take a look at the other results that I got. So if I look at the results together, this was 2 out of 10, this was 2 out of 10, and this was 1 out of 10. That's going to equal 5 out of 10. So altogether, that's the other half of the circle. So I'm happy that these all add up to the second half of the circle. One thing that maybe is a little bit different than what I might expect. I might have expected to have brown be a little bit higher because there's a little bit more brown here than there are the other colors. So I might have expected brown to be a little bit higher. But it's not totally strange to have it a little, to equal to, because there's not that much difference between it. Red, I feel pretty happy with red, and then orange I might have expected, red I'm happy with, and orange I'm happy with. Okay, so if the brown were to go up, the orange might have gone, the red might have gone down one. All right, but other than that, I'm pretty happy with these results. But you might get results, it might land on green 10 times. All right, and it might land on the other colors no times. That can happen. All right, is it very likely to happen? Probably not. All right, because we're talking about what is probably going to happen. And that's kind of what we want kids to get the idea of. What is probably going to happen here? All right, just because it's probably going to happen based on what we know, it doesn't mean that's exactly what is going to happen. So we just try to use some of this language, give kids more experience with these frequency tables, let them use the spinners, make spinners and use them, and just use the basic probability language. And so as far as how you can help with this at home, use these words, right? Ask them how likely something is to happen. Yeah, I mean, you can make the spinners if you want, of course. I mean, that's just a fun activity if kids want to do that and decorate them with, I don't know, polka dots or squares or whatever. It doesn't even have to be colors in there. It could be anything, actually. But just use the language. How likely it is. It's likely. It's not very likely. And just get them practicing with that. And you could do it with anything. I mean, do it with how likely it is to rain if you want. Look at some of the weather graphs you've made and make predictions for the next little bit. Or even something for dinner. How likely is it that you guys are going to have pizza for dinner? All right, and I think you can use that just to bring more of the language up. I think it'll bring more awareness to how to use the words. Okay, and hopefully help kids get a better understanding of it. So this is lesson 11.3, Spinner Experiments, the Parent Help video for grade 3 Everyday Math.